Hello everyone. In this video, I'll explain how we can apply K-means algorithm for clustering the two-dimensional data set. So let us consider an example here. So in this example, here we have various data points. You can see it is a two-dimensional data point A1 with the coordinates 2 and 10 here. Then you can see A2. So these are all various data points. So what we have to do is we have to cluster this into we are going to cluster this into 3 clusters. So here it is given we have to cluster into 3 clusters. So how will you do this? So first initially we will select 3 centroids, that is we need 3 clusters, so we will be selecting 3 centroids. So let us randomly select 3 centroids here from out of this data set. So let us choose this A1, this B1 and C1 as our initial centroid. So the initial centroid we have chosen it as A1, B1 and C1. Now let us denote X1, X2, X3 denote A1, B1 and C1. So these are the centroids we have chosen. Now here on the right hand side we can see that we have plotted it on the graph. So we can see that there is an x-axis and y-axis. So each the coordinate represents, suppose A1 2, 10 means 2 is the x coordinate and 10 is the y coordinate. Similarly for all other points. So here we have plotted all the data points into an axis, xy axis. Now what we have to do is we have chosen A1, B1 and C1 as our initial centroids. So A1 is 2, 10, then B1 is, we know here it is 5, 8 and C1 is 1, 2. So here we have all the values or the coordinates of all the centroids. Now the second step is you have to calculate the distance between each data point with the centroid. So we have all the centroids given x1, x2, x3 and we have all the data points, that is A1, A2, A3, then B1, B2, B3 and C1, C2. These are the data points given in the question. So what we'll be doing is, here we know that we have taken this x1, x2, x3 as the centroids and these are our data points A1, A2, A3, B1, B2, B3. Each one is a two-dimensional data point. So what we will do is we will be finding the distance between each data point and this centroid, each centroid. So first let us consider this x1. x1 is A1 2, 10. So what is the coordinate of A1 here? So a coordinate of A1 is 2, 10. So there is the distance between that and this is 0. Then let us consider A2. So we will take A2 coordinate. A2 coordinate, as you know, it is 2, 5, right? Here in this question you can see that A2 is 2, 5. So we have chosen the first point, that is a centroid, as 2, 10, and our second point, that is we have chosen, we are going to calculate the distance between these 2 points. How will you do that? It is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square under root. So when you use this formula, you will be getting the distance between these 2 points. So we have to use this formula for finding the distance between each point. So we know that A2 coordinate we know. So that A1, X1 coordinate also we know. We have to find the distance between A2 and this X1. Then we need to find the distance between A3 and x1. Similarly, b1, x1, b2, x1, b3, x1, c1, x1, c2, x1. So these are the values or the distances between each data point with the initial centroid which we have taken, that is A1 centroid. We are getting the distance. So that is in this first row we have filled the distance between each data point to the first centroid. Now let us consider the second centroid. Second centroid is x2, that is b1 5, 8. So what we will be doing, we have all the data points a1, a2, a3, b1, b2, b3, c1, c2. So we have to find the distance between each data point to the centroid. So the centroid which we are considering right now is b1, that is x2. So 5, 8. So we'll be finding the distance between a1 and this x2, then distance between a2 and this x2, then b1 x2, b3 x2, c1 x2 and c2 x2. So these are the values which we got, that is the distance between each data point and the centroid. How will you find it? The distance is x2 minus x1 under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. It is Euclidean distance, so that this is how we will be finding the distance. So we have filled all the distance values here in this matrix. So this is a distance matrix, and now we have one more centroid remaining, that is x3, which is corresponding to c1 1 comma 2. So we'll be again finding each data point's distance from the centroid, that is distance between a1 and the centroid x3, distance between a2 and x3. So this value is the distance between a1 and x3. This is the distance between a2 and x3. This is the distance between a3 and x3. Similarly, all other data points will be finding. So we got all the distance between all the data points with the third centroid here in this third row. So you can see that in this matrix, whatever values which we got here, the entry to this one is all distance between the data points and the centroid. So here we have chosen 3 centroids. So we have 3 rows here corresponding to each centroid, distance between the data points and the centroids. Now, once we have found this distance, next is the object clustering. So what we do is we have to take the objects with minimum distance. So we have to assign each object based on the minimum distance. So here when you consider this first row, we can see that, or here in this first column a1, for a1 we can see for this is the data point a1. So a1, when you see this column, you can see the values are 0, 3.61 and 8.06. so these are the distance between centroid and all the 3 centroids and the data point a1. So out of this one, what is the 0? 0 is the distance between the data point a1 and the first centroid, that is x1. This 3.61 is the distance between, this is the distance between the data point a1 and the second centroid, that is x2. 8.06 is the distance between a1 and the third centroid. Similarly, the second column, we can see that it is the first row indicate the distance between a2 and the centroid x1. Second row indicate the distance between a2 and the second centroid x2. The third row indicate the distance between a2 and the third centroid. So every data point we have the distance calculated for each centroid. So in the first column, when you observe it, the value 0, 3.61, 8.06. So out of this we have to choose the minimum distance. So here we can see the minimum distance is 0. So 0 is corresponding to which centroid? It is corresponding to the centroid x1. That means a1 should be assigned to this x1 group, that centroid, which is that we will be, this is the cluster, 3 clusters we are taking. So the first one we will be taking a1 to x1. Then in the second column we can see that the values, that is 5, 4.24 and 3.16. out of the 3 values, 3.16 is the minimum. So that is corresponding to which centroid? It is corresponding to x3. That means a2 should be assigned to this group x3. Now, let us consider this third column. Third column, when you take 8.48, 5 and 7.28, that means A3, 5 is the minimum out of this. 5 is corresponding to which one? Centroid X2. That means this A3 should be assigned to that group X2. Then what about this B1? That column, we can see that 0 is the minimum value. So it is corresponding to centroid X2. So B1 will be going to group X2. Then here we can just see x1 corresponds to group 1, x2 corresponds to group 2, x3 corresponds to group 3. Let us consider like that. Then B2, the minimum value is 3.61. That means B2 is assigned to the second group. Then again B3, we can see B3 is also having a lower value, that is 4.12, which is corresponding to the second centroid. So it is clustered onto the second group. Then C1, we can see here, C1 is, the minimum value is 0. So 0 is corresponding to the third centroid. So that will be grouped onto the third group. And C2, in C2 column, we can see 1.41 is the minimum value, minimum distance. So that is corresponding to centroid 2. So C2 will go to group 2. So we can see that all here A1 is given to group 1, then A3, B1, B2, B3, C2 are assigned to group 2 and A2 and C1 to group 3. So now we will just form another matrix in which the assignment can be easily visible. So what we do is, here there is a matrix. Here we have put all the data points here, that is A1, A2, A3, B1, B2, B3, C1, C2. These are all data points and these are all our centroids. Now what we do is, whichever centroid it has been, that this corresponds to group 1. This is corresponding to group 2. This is corresponding to group 3. So we know that A1 is assigned to group 1. So we are just entering a value 1 there, which is corresponding to that group 1. Then A2, wherever it is, which group it is assigned, that group we are giving 1 over there. So in A2 column, we are putting 1 over the group 3 because A2 is assigned to group 3. In A3 column, we are assigning 1 to the second row, that is, it is assigned to group 2, and B1 it is assigned to group 2. Similarly for other data points also. So this is just from the previous group, we have just assigning one value 1. So element of group matrix is 1 if and only if the object is assigned to that group. So this is how we can assign that elements into various groups. That was the initial iteration. Now we will go to the next iteration, that is iteration 1. So here what we do is, we have to determine the centroid. Now how will you determine the centroid? Because we know that if you observe here this one, we know this A1 for this first group, we have only A1, only one data point assigned to group 1. Then if you see the second group, how many data points are assigned to second group? We can see the entries 1 here, that are all assigned to group 2. So we can see A3 is assigned, B1 is assigned, B2, B3 and C2 assigned to group 2. So we have 1, 2, 3, 4, 5 data points assigned to group 2. And in the third one, we can see how many. This A2 is assigned to group 3. Then C1 is assigned to group 3. So in the last row, we can see there are only 2 entries as 1. That means only 2 data points are assigned to that particular group, group 3. Now for finding the centroid, what we do is, here from the first point, that is in group 1, we have only 1 point. So we can directly write that as the centroid. So that is here we got x1, that is 2, 10, because A1 point is 2, 10. Now if you see x2, we know that there are 1, 2, 3, 4, 5 data points are assigned to group 2. So what we do is, we have to find the centroid. How will you find the centroid? Take the x coordinates of each data point, add it and divide by the number of data points, that is 5 data points we have. So we are taking the average basically, and y coordinate also we will take the sum and divide by the number of points. So we have all 5 points here. So what we do is, we are taking in x2, what we do is we are taking the x coordinate of each data point, add it and divide by 5. Similarly, y coordinate we are adding all the y coordinate and dividing by 5. So finally we are getting it as 6, 6 as the centroid for the second group. Now for the third group, we know there are 2 data points, that is A2 and C1 is assigned to group 3. So this 2 x coordinate of this 2 A2 and C1, we are adding it and dividing by 2, and y coordinate of A2 and C1 we are adding it and divide by 2 to get the average. So we got the average value as 1.5 and 3.5. So we got the centroids now. So after the centroid, what we do is, we have to find the distance. Now we will be again forming the same matrix which we have formed in the previous step, that is the distance matrix. Now we have all these points, that is x1, x2, x3 also. I forgot to put it here. This is 1.5 and 3.5. So we have all these points x1, x2, x3. Now what we do is, all the data points, that is A1, A2, A3, B1, B2, B3, C1, C2, all these data points distance from each centroid we are calculating and putting it inside the distance matrix. That is the first row here. The first element represents the distance between A1 and this data point x1. Then the second element, second row in the first column, represents the distance between A1 and the second centroid. And the third row indicates the distance between the A1, data point A1 and the third centroid. Similarly, for all other data points, we will be evaluating the distance and will be completing this distance matrix. Now, once you have obtained this distance matrix, next step is you need to do the clustering. How will you do the clustering? Because based on the minimum distance criteria, we have to cluster the object into various groups. So here we have three centroids. So here we have three groups, G1, G2, and for example, group 1, group 2, and group 3. So which all data points we are assigning to group 1, which all data points will be assigning to group 2, and which all data points will be assigning to group 3. It depends upon the minimum distance criteria. So if you see this A1, let us see this A1. So in this particular column, you can see this is the minimum value. So it is corresponding to group 1. That means A1 is assigned to group 1. Now in second column, if you observe it, we can see this 1.58 is the minimum value. That means A2 is grouped into the third group. That is third group. You can see here, third group. Now, the third column, A3, if you see, you can see that it is 2.83 is the minimum value. So that A3 is assigned to group 2. So it is group 2 is coming here. So similarly, we will find for each the data point where it is grouped onto, which group it is assigned to. So now we are assigning all those things. So now here we can see that A1 is assigned to group 1. That is why we entered a 1 there. So whichever group it is assigned, we are making an entry 1 there in the matrix. So here by seeing this matrix, we can easily find group 1. So this is group 1. Which all elements are assigned to group 1? We can easily see that only A1 is there in this. No, not A1. A1 and C2 are there in this group. So in the first row, we can see A1 and C2 there. In the second row, we can see A3, B1, B2, B3. So this all four elements will be grouped into this second group. Now third row, if you see, we can A2 is having 1, then C1 is 1. That means A2 and C1 is assigned to group 3. So now we got all the data points where it is grouped into. Now the next step is we have to find the centroid. So the same process will be repeating. So how will you find the centroid? Here in the first one, first data point, we have A1 and C2. There are two elements. So what we do is we'll take the x coordinate of A1 and x coordinate of C2. We add it and divide by 2 to take the average. Similarly, the y coordinate also we will take, add and divide by 2. So we'll be getting this first centroid as 3 and 9.5. How will you find the centroid for the second one? Second one, we can see that the points are entries 1 here for A3, B1, B2, B3. So 1, 2, 3, 4. 4 data points are there in this group. So what we do, the x coordinate of A3 and x coordinate of B1, x coordinate of B2, x coordinate of B3. We take the sum and divide by 4. Similarly, the y coordinate of A3, B1, B2, B3, we take it out and sum it up and divide by 4. So we'll be getting the coordinates for centroid for the second group. What about the third group? Third group, we can see in the third row, we can see the entry for A2 is 1 and entry for C1 is 1. That means that A2 and C1 are assigned to group 3. So we'll be taking the x coordinate of A2 and x coordinate of C1. We will add it and divide by 2 to take the average. Similarly, the y coordinate of A2 and y coordinate of C1, we will take divide by 2. So we'll be getting the centroid. So we got 3 centroids here. Now what we have to do? Now we have to find the distance between each data point with respect to this centroid. So we have 3 centroids. So we need to find all the distance between the data points and the centroid. We have the new centroids here, x1, x2, x3, and all the data points A1, A2, A3, B1, B2, B3, C1 and C2. So the distance between A1 and x1 is coming into this A1, A2. All these elements distance between that particular data point and the first centroid is coming in the first row. Second row is with respect to the second centroid, and third row is with respect to the third centroid. So now what we have to do is we have to, under this particular column, you just check which is the minimum distance. So minimum distance, we can see 1.12 is the minimum distance. That means A1 is assigned to group 1. Now in the second column, we can see this is the minimum value. So A2 is assigned to group 3. Now in the third column, we can see 1.95 is the minimum value. So that means A3 is assigned to group 2. Similarly, for B1, we can see it is 2.5. So that is assigned to group 1. In the under B2 column, we can see 0.56 is the minimum value. So it is assigned to group 2. Here under B3 column, we can see 1.35 is the minimum value. So it is assigned to group 2. Then under C1 column, we can see 1.58 is the minimum. So it is assigned to group 3. And here in C2 column, we can see that it is 1.12 here. So it is assigned to group 1. So now the same thing, wherever we have assigned that particular one, for group 1, we are entering it as 1 wherever that assignment is done. So from this matrix, wherever one entry is there, it corresponds to that particular group. 1 here means it is to group 1. 1 in the second row means those data points are assigned to second group. And in third row, which all data points are having entry 1, that means it is assigned to group 3. Now we have all assigned this one. So in group 1, we have 3 data points, A1, B1 and C2. Then here in group 2, we have A3, B2, B3. And in group 3, we have A2 and C1. So in group 1, we have 3 data points. So we'll be taking the x coordinate of each data point, sum it up and divide by 3. Similarly, y coordinate also sum it up and divide by 3 to get the centroid. So we got the centroid here. Similarly, for x2, we can see 1, 2, 3. 3 data points are assigned to group 2. So all these 3 x coordinates we will take, add it and divide by 3. Similarly, y coordinates we will take and divide by 3. So we'll be getting the data point for the centroid for the second group. Similarly, the third row, that is for the third group, we can see A2 is assigned to group 3, C1 is assigned to group 3. So we'll be taking the x coordinate of A2 and x coordinate of C1, add it and divide by 2. Similarly, y coordinate of A2 and y coordinate of C1, add it and divide by 2. So we will be getting the third centroid. So we got all the centroids here. Now what we do is we have to now find the distance. Now from this all the centroids, we are finding the distance of each data point. So data point initial values we know, from that value we are finding the distance between centroid and that data point. So here we are entering the same step we are repeating here. So the first one is for G1, that is for group 1, this is for group 2 and this is for group 3. So these are all evaluated distance matrices. Distance, you know how to evaluate. It is a square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. It's Euclidean distance. And now here in A1, under this column, we can see the value which is having a minimum value is this one. So this value is assigned to group 1. Under A2 column, we have 1.58 as minimum. So that is assigned to group 3. Here it is assigned to group 2. Here this one is minimum. So it is assigned to group 1. This is minimum. It is assigned to group 2. Then this is minimum. So it is assigned to group 2. Under C1 column, 1.58 is minimum. So it is assigned to group 3. Under C2 column, 0.33 is minimum. So it is assigned to group 3. So we can see here this is the grouping. So under for group 1, this is group 2 and this is group 3. For under group 1 we have A1, B1 and C2. Under group 2 we have A3, B2, B3. In group 3 we have 1 and 1. So when you compare this one with the previous previous step, we can see that the data points in the groups, that is G1, G2, G3 remains the same. It is not moving into a new group. So if you compare this iteration with the previous iteration, we can see that for example, here in group 1, we have A1, B1 and C2. So in the previous iteration also, under group 1, we were having A1, B1 and C2. And in group 2, we were having A3, B2, B3. And in group 3, we are having A2 and C1. So there is no change in the group data values. That is, the objects are not moving into a new group. That means that it has the k-means algorithm has reached its stability. So we can finally cluster the group as group 1. The values are A1, B1, C2. group 2 A3 B2 B3, group 3 A2 and C1. So we can actually show on diagram also. This is how we have plotted all these values, that A1, B1, all these values data points are here. We can see that this one A1, B1, C2. So this one is our group 1. Then A2 and C1, this is our group 3. Here we can see, and this one is B2, B3 and A3. This is our group 2. So by observing this clustering, we can see that those data points which are closer to each other, they are grouped into the same cluster. So this is how we can use the K-means algorithms for solving for clustering the data points which are the two-dimensional data points. And I hope you understood. And the stopping criteria for this is you have to check for the last two iterations wherein which there is no change in the data points, means group data points. In each group, the data objects are not moving into new objects. So if the group remains the same in two iterations, that means that it has reached the stable state. So we can stop it there. So this is the stopping criteria for this K-means algorithm for a multidimensional data. So hope you understood. Thanks for watching. Thank you all.